According to industry experts, achieving that level of technological substitution likely won't happen before the end of this decade at the very earliest. What's emerging instead is a genuinely patchwork system, one that's keeping Russia's existing aircraft fleet technically operational, but with steadily declining reliability across the board. This imbalance is squeezing Russia between two genuinely unappealing options. The first option involves keeping jets stationed at forward bases close to the front line, like Saki, which allows for quick combat response, but leaves those same aircraft sitting squarely within Ukraine's steadily expanding drone range. The second option involves pulling aircraft much further back into supposedly safer territory, which does offer better protection, but introduces an entirely different set of costs. Longer flight distances wear down engines and airframes faster, increase overall maintenance burden, and reduce how many sorties an aircraft can realistically fly each day. Pilots end up spending significant flight time simply traveling toward the front before they can even begin their actual mission. Then there's the fuel dimension to consider as well. While precise data here remains somewhat limited, given Ukraine's ongoing campaign against Russian oil refineries, flying aircraft from significantly further back, over considerably longer distances, likely adds meaningful additional strain to an already stretched fuel logistics network. Ground crews already dealing with part shortages now also have to manage tighter fuel allocations, stretching an already thin support system even further. What Ukraine is executing across Crimea represents exactly this kind of pressure, and it's part of a much broader, deliberately planned campaign that extends well beyond these individual strikes. This campaign actually has a formal name and a defined timeline attached to it. In late June, President Zelensky launched a 40-day operation specifically designed to escalate sustained pressure on Moscow. This isn't a loosely organized series of scattered attacks. It's been explicitly defined as a deliberate influence operation, aimed at ultimately forcing Moscow toward genuinely ending the war. The bulk of this operation consists of long-range strikes against high-value targets scattered across occupied territory. The strikes on Saki and Hvardiiske represent just the most visible, most publicly documented links within this much larger, more comprehensive operation. The underlying military logic guiding this campaign also has its own name: parallel operations. Under the more traditional approach to warfare, attacks generally happen sequentially. One target group gets struck, results get carefully assessed, and only then does attention shift toward the next target. Parallel operations instead load multiple points across an enemy's entire system simultaneously. The actual goal here isn't destroying any single target in isolation. It's shaking the entire interconnected system all at once. An airbase, the radar network protecting it, the energy infrastructure, feeding that radar, and the refinery supplying fuel to the aircraft launching from that base, these are all interconnected gears within the same broader war machine. When multiple gears get struck simultaneously, the enemy has dramatically less time and fewer resources available to repair damage, redistribute assets, or reassure anyone that everything remains firmly under control. Ukraine is achieving all of this without relying on a large conventional air force at all. Instead, it's using a considerably cheaper toolkit built around drones, missiles, sabotage operations, and specialized units working in careful coordination. A key reason this approach works so effectively against Crimea's air bases specifically comes down to sequencing. Before Ukraine strikes a given base directly, it typically targets the air defense systems protecting that exact base first. According to available reports, hundreds of Russian air defense systems and radar installations were destroyed or damaged throughout 2025 alone, with much of that damage visually verified afterward. Every radar system successfully blinded opens up another gap in the broader protective umbrella covering Crimea. This sequencing matters more than it might first appear. A single successful strike on an airbase without first neutralizing the radar and missile coverage protecting it would likely fail, or at best cost Ukraine several expensive drones for a single hangar. By methodically clearing the air defense picture first, Ukraine turns each subsequent strike into a far cheaper, far more reliable operation. It's the difference between kicking down a locked door and simply walking through one that's already been left open. All of this tactical success is actually masking something far deeper and more structural for Russia. Russia's genuine ability to compensate for lost aircraft remains weak, and not solely because of ongoing sanctions. There's a more fundamental problem underneath all of this. Russian military aviation has genuinely fallen behind an entire technological generation. Nowhere is this more visible than in Russia's strategic bomber fleet. Most of the aircraft currently carrying long-range missiles deep into Ukrainian territory, the Tu-95 Bear and the Tu-22 M3 Backfire, are Cold War-era platforms, with designs dating back roughly half a century, growing increasingly difficult and expensive to maintain with each passing year. Russia has spent decades trying to modernize this aging fleet. The new generation stealth bomber program it designed specifically for this purpose remains, practically speaking, a ghost project. It's struggled with persistent delays for years now. As of 2026, there's still no independently verified prototype flight on record, and serial production estimates have already slipped toward the 2030s. That delay isn't simply bad luck, it's genuinely structural. A modern stealth bomber depends heavily on exactly the advanced materials, engines, and electronics that international sanctions have directly targeted. What truly illustrates just how serious this gap has become is a simple comparison. While Russia remains effectively trapped, relying on half-century-old aircraft designs, the United States has already moved its new generation B-21 Raider stealth bomber into serial production during this exact same period. So the gap separating these two nuclear powers isn't closing at all. It's steadily widening instead. This issue extends well beyond bombers alone. It represents a symbol of a much broader, genuinely vicious cycle affecting all of Russian military aviation, because producing a capable strategic warplane ranks among the most technically demanding tasks any military industry can undertake, and Russia is rapidly losing that particular capability altogether. Every single jet Ukraine strikes across Crimea directly touches this exact open wound. Russia currently cannot adequately replace the aircraft it's losing today, and simultaneously, it's steadily losing the broader capacity to produce tomorrow's aircraft as well. That's precisely why every loss sustained in Crimea steals not just from Russia's present military capability, but from its future capability too. This entire picture is genuinely impressive from Ukraine's perspective, but it's also worth placing it into proper, honest perspective. These attacks don't mean Russia's air power across Crimea is finished entirely, nor do they mean concrete shelters have become completely useless as a defensive measure. Above all else, these shelters are still performing their intended function most of the time. The fact that concrete shells can occasionally be penetrated doesn't automatically mean they're worthless. They still successfully absorb the majority of incoming attacks, still require genuinely precise hits to fail, and still successfully defeat many threats aimed at any given base. Neutralizing a hardened shelter remains many times more difficult than simply striking an aircraft sitting out in the open. So Russia's substantial concrete investment hasn't gone entirely to waste. It simply can no longer deliver the absolute guaranteed security it originally promised. It's also worth staying appropriately cautious about the full scale of reported damage here. A significant portion of these claims comes directly from Ukrainian sources, and genuinely independent verification remains somewhat limited. While satellite imagery can clearly demonstrate structural damage to a given hangar, it alone can't definitively prove which specific aircraft were actually stored inside at the time or confirm the complete scale of Russia's losses. Some of the aircraft reported as destroyed may only be lightly damaged, repairable within weeks rather than permanently written off. Second, Russia remains a power genuinely capable of adapting to this evolving threat. It can further reinforce existing shelters, strengthen the air defense systems protecting these bases, and disperse aircraft toward comparatively safer locations further from the front. Ukraine isn't going to erase Russian air power from the map through a single sustained campaign alone. Expecting that kind of outcome would be genuinely unrealistic. It's also worth considering an alternative reading of these attacks. Perhaps they signal not Ukraine's overwhelming strength, but rather its current constraints. Because Ukraine currently lacks the capacity to launch a full ground operation aimed at actually recapturing Crimea outright, it may instead be choosing to steadily erode Russian capability there from a distance, using precision strikes as a substitute for territorial recapture. But none of these reasonable objections actually refute the essential point here. They simply help frame it more accurately. Because every single adaptation step Russia takes in response also carries a genuine cost of its own. More concrete requires more money. Relocating bases further from the front line slows operational tempo considerably. And perhaps most importantly, what Russia is steadily losing here isn't purely physical or material. It's something closer to confidence itself. If a hardened shelter has effectively become not an absolute guarantee of protection, but merely a trench that buys additional time before an eventual strike succeeds, then every technician, every pilot, and every aircraft stationed at that particular base no longer feels genuinely, completely safe anymore. In warfare, that kind of persistent uncertainty often proves just as exhausting and corrosive as the physical damage itself. There's a psychological dimension here that rarely gets discussed in these breakdowns, and it deserves a moment of its own. Pilots who once trusted that returning to base meant returning to safety now have to factor in the possibility that the hangar itself might not survive the week. Ground crews working inside these shelters know the doors were designed to keep threats out, not to guarantee they always would. That mental shift from feeling protected to feeling merely delayed changes how an entire base operates. Maintenance happens faster, sometimes at the cost of thoroughness. Aircraft get moved more frequently between shelters, adding wear and complexity to already strained logistics. None of this shows up cleanly in a damage assessment, but it shapes everything happening on the ground, at these bases every single day. Think about what this really represents when you step back from the individual strikes and satellite photos. Russia poured concrete for years, believing thickness alone could solve a problem that had actually evolved into something entirely different. The war moved from a question of physical protection into a question of precision, timing, and system-wide disruption. And Russia's defensive doctrine simply hasn't caught up to that shift yet. Every hangar that gets struck doesn't just cost Russia a jet, it costs Russia a piece of the confidence that made this entire defensive strategy feel viable in the first place. So here's the real question worth sitting with as this campaign continues unfolding. If Russia can't reliably protect the aircraft it already has, and can't reliably build the aircraft it will eventually need, how much longer can Putin genuinely defend a fleet he has no real path left to replace? Let me know what you think in the comments below. If this breakdown helped you understand what's actually happening across Crimea's air bases right now, hit like. Share it with someone following this conflict closely, and subscribe, because this campaign is far from finished, and the next round of strikes could tell us even more about where this war is genuinely headed. Title: Nowhere to Hide. Ukraine cracks. Putin's concrete bunkers. In Crimea script, what do you do when the fortress you spent 2 years building turns out to have a hole in the roof nobody noticed until it was too late? That's the exact problem Vladimir Putin is facing right now in Crimea, and the footage coming out of it is genuinely remarkable. Before we get into how this happened, hit like, subscribe, and share this with someone who's been following the air war over Ukraine, because this particular story hasn't gotten nearly enough attention yet. For close to 2 years, Russia worked on solving one specific problem. Its warplanes, worth tens of millions of dollars apiece, were sitting ducks against Ukraine's rapidly improving drone arsenal. Putin thought he'd found the answer: thick concrete walls, reinforced roofs, fully enclosed hangars designed to swallow a fighter jet whole and keep it safe from anything flying overhead. Russia built these hardened shelters across its air bases, especially throughout occupied Crimea, and quietly tucked its most valuable aircraft inside them, believing the problem was finally solved. It wasn't. Ukraine just proved in the most public way possible that concrete alone doesn't guarantee safety anymore. In modern warfare, hiding a jet behind a wall isn't the same as protecting it. And Putin is learning that lesson again and again, one destroyed aircraft at a time. The clearest evidence of this arrived in the first days of July 2026, and it arrived twice in rapid succession. On July 1st, Ukraine's security service struck the Saki military airfield, hitting several hardened hangars and the aircraft sheltered inside them. That alone would have been significant. But Ukraine wasn't finished. Just 2 days later, on July 3rd, the same base got hit again, and this second strike was considerably heavier than the first. According to Ukrainian sources, 7 separate hangars sheltering aircraft were struck in that second wave, and at least 7 Russian warplanes were either destroyed outright or seriously damaged. Among the aircraft reportedly caught in the strike were Su-30SM multi-role fighters, some of Russia's most valuable combat platforms on the southern front, along with Su-24 frontline bombers. In the same broader operation, another critical Crimean base, Hvardiiske, was hit as well, with hangars storing Shahed-type drones and aviation equipment also targeted directly. Hitting the same general area twice within a single week wasn't a coincidence. It was a clear signal that this was a deliberate, systematic campaign, not a one-off lucky strike. So why does Ukraine keep coming back to Saki specifically? The base sits on Crimea's western coast, near the settlement of Novofedorivka, and functions as one of Russia's most important naval aviation hubs on the Black Sea. Su-24 and Su-30SM aircraft launching from Saki support Russian operations across southern Ukraine, dropping guided bombs on frontline positions and providing air cover for naval activity. Saki isn't simply a parking lot for jets. It's one of the actual launch points for attacks aimed directly at Ukraine. Hitting it means striking Russian air power right where it originates. Hvardiiske plays a similarly important role. This base hosts both tactical aircraft and the Shahed drones responsible for regularly striking Ukrainian cities, making it another essential link in Russia's broader attack chain. Targeting Saki carries symbolic weight, too. Back in August 2022, massive explosions rocked this same base, sending an unmistakable message to the entire world that even Crimea, territory Moscow had long treated as untouchable, was no longer beyond Ukraine's reach. In the years since that incident, Russia poured enormous effort and money into hardening these bases against exactly this kind of attack. Concrete shelters sat at the very center of that defensive strategy. That's precisely why the satellite imagery released after this most recent attack felt so striking. In those images, the massive blast doors protecting several hardened shelters had been torn completely off their frames, and the roofs of multiple hangars showed clear signs of direct penetration. The concrete Russia had spent years pouring and reinforcing now sat riddled with holes. Understanding exactly how this penetration became possible is worth digging into on its own, because Russia's original logic wasn't unreasonable. In the war's earliest phase, Russian jets were often parked either completely in the open or inside thin metal hangars, since Moscow had spent decades trusting the sheer distance between its air bases and the front line, combined with the depth of Russian-held territory, to provide adequate protection. But Ukraine's steadily expanding drone range and improving accuracy completely undermined that assumption. Once long-range drones started reaching bases across Crimea and beyond, aircraft sitting out in the open effectively became stationary targets. At that point, Russia turned to a solution Western militaries have relied on for decades: hardened aircraft shelters, built with thick reinforced concrete walls, steel-reinforced roofs, and heavy blast doors. These structures were designed to absorb fragmentation damage and prevent a single strike from taking out multiple aircraft at once. In theory, pulling a jet inside one of these shells should have made it nearly untouchable. But Ukraine found more than one way to crack that shell open, and in doing so, made Russia's problem considerably more complicated. The first issue involves the munitions themselves. According to Ukrainian officials, newer generations of long-range drones can now carry warheads weighing up to 200 kilograms, more than enough explosive energy to exceed the protective threshold these shelters were originally designed to withstand. But what really matters here is how that power actually gets applied. If a shelter's strongest point is its thick front wall and heavy blast door, its weakest point is almost always its roof. A drone descending at a steep angle can target that thinner overhead surface directly, exploiting exactly the structural weakness these shelters were never fully designed to eliminate. On top of that, the hangars Ukraine struck likely had their protective blast doors sitting open at the time, whether for routine maintenance or basic air circulation. A single strike entering through an open door renders all that surrounding concrete essentially meaningless, no matter how thick or well-engineered it happens to be. And even when a strike doesn't fully penetrate the structure, the resulting damage can still prove lethal to the aircraft inside. A warhead detonating within an enclosed space generates a pressure wave that amplifies dramatically within that confined area. An aircraft's most sensitive components, its avionics, radar systems, fuel lines, and weapon systems, are extraordinarily vulnerable to that sudden spike in pressure and heat. Even if a jet looks completely intact from the outside afterward, it may never fly again, its internal systems effectively destroyed by the shock wave alone. Then, there's the concrete's own unfortunate betrayal. In a sufficiently powerful explosion, even heavily reinforced, concrete begins to fracture, sending fragments and shrapnel scattering off its interior surfaces at extremely high velocity, filling the enclosed hangar with additional deadly debris. The very structure built to protect the aircraft ends up becoming part of the threat itself once it's struck with enough force. But there's a deeper truth running underneath this entire situation that's easy to overlook. Ukraine's real objective here likely isn't simply destroying individual aircraft one at a time. Modern air power doesn't function through aircraft alone. It relies on an entire interconnected system that keeps those aircraft consistently flying. A fighter jet is an extraordinarily demanding piece of machinery. Before it can take off, its engines need thorough inspection, its avionics need testing, and its weapons need proper loading. All of that depends on skilled mechanics, available spare parts, functioning ground support vehicles, working fuel lines, and technicians operating safely within a protected environment. What we casually call air power actually functions more like a continuously turning wheel. A jet takes on fuel, gets armed, launches, strikes its target, returns to base, and then gets refueled and rearmed by an exhausted ground crew preparing it for the next mission. What Ukraine is genuinely attacking is that entire wheel, not just the jet sitting at its center. Shooting an aircraft out of the sky isn't actually necessary to achieve the desired effect. Destroying a hangar, a maintenance workshop, a fuel depot, or critical ground equipment is often enough to completely disrupt a base's operational rhythm. Under this logic, a jet that simply can't take off today becomes just as operationally useless to Russia as a jet that was never built in the first place. And slowing down that wheel has a direct, tangible impact on the fighting happening along the actual front line. Because the jets launching from bases like Saki and Hvardiiske aren't flying purely symbolic missions. They're delivering one of the most feared weapons currently used against Ukrainian positions, guided glide bombs. These weapons started life as ordinary unguided heavy bombs, but once fitted with wing kits and guidance systems, they transform into precision munitions capable of gliding dozens of kilometers toward their target. A Russian jet can release these bombs from a relatively safe distance without ever needing to approach the front line directly, and still devastate Ukrainian trenches and defensive positions below. That's exactly where the connection becomes clear. If a burning hangar at Saki grounds several Russian jets for days at a stretch, that could realistically translate into fewer glide bombs falling on a specific Ukrainian unit at the front during that same window. This obviously isn't a perfect one-to-one equation, but the underlying logic holds up. As the number of Russian sorties launching each day drops, the volume of fire landing on frontline positions theoretically eases as well. In a grinding war of attrition, where progress often gets measured in single meters, these smaller differences tend to accumulate steadily over time, eventually adding up to something genuinely meaningful. And that's only the military side of this equation. There's also a purely economic dimension to every aircraft Russia loses, and that particular bill gets written using math that overwhelmingly favors Ukraine. Let's pause here for a second, because the numbers behind this economic imbalance are genuinely worth sitting with. If you're finding this breakdown interesting so far, drop a comment letting me know whether you think Russia can actually adapt fast enough to close this gap, and stay subscribed. Because what comes next explains exactly why replacing these aircraft has become such a serious structural problem for Moscow. The cost of the long-range drones Ukraine typically uses in these strikes generally falls somewhere between $10,000 and $100,000, depending on the specific model and payload involved. Compare that to the price of a single Su-30SM multi-role fighter, the exact kind of aircraft these drones are. Targeting, which runs somewhere between $35 and $50 million depending on its specific configuration. Alongside the aircraft itself, Russia often loses something even harder to replace. A fully trained combat pilot, someone who typically represents years of specialized training and enormous accumulated investment. Replacing a destroyed jet with a brand new one presents an entirely separate and much deeper problem for Russia, because the production of aircraft like the Su-30 sits directly within the crosshairs of Western sanctions. Sukhoi and its parent manufacturer, the companies responsible for producing these jets, were explicitly placed on international sanctions lists. Yet the internal components of these aircraft, everything from navigation hardware to flight control computers, had depended for years on parts imported from Western suppliers. Once sanctions closed off that supply route, Russia turned to shadow procurement networks running through countries like the United Arab Emirates, Turkey, and China to keep sourcing critical components. Those networks are still functioning today. According to one investigation, more than 4,000 individual parts shipments have reached Russia over roughly 3 years through these workaround channels. But this isn't a genuinely durable long-term solution. Parts arriving through these indirect routes are frequently uncertified, carry uncertain operational lifespans, and grow increasingly expensive over time. This uncertainty also raises real safety concerns for the aircraft ultimately relying on these components. So can China simply fill this entire gap on its own? Partially, but not completely. China's exports of aircraft parts to Russia have roughly quadrupled since the war began, now approaching nearly $1 billion annually. Even so, China hasn't yet managed to offer a fully reliable substitute for Western technology, particularly in the most critical areas like advanced engines and sophisticated avionics systems. According to industry experts, achieving that level of technological substitution likely won't happen before the end of this decade. At the very earliest, what's emerging instead is a genuinely patchwork system, one that's keeping Russia's existing aircraft fleet